All right. Hello, everybody. Welcome to this week's Anti-Cast Webcast. We've got Evan and Luke. We've got deploying emergency comms with drones and stuff and mesh. Is that like a spider web mesh? What's a mesh? I guess we're gonna figure that out. They're gonna tell us here in their presentation. I'm just gonna let them take it over. I'm gonna head backstage. We'll come back at the end of the presentation for Q&A. So throw us your questions in the Zoom Q&A if you're in Zoom or in Discord. It might be better to save those for the end in Discord because they're just gonna get lost. But jump in the Discord, jump in Zoom, and I will see you guys towards the end. It's all
Sounds
you.
good. Mesh, so like a spider web, but if you walk through it and you actually feel something, it's probably not physically healthy for you. You might want to turn down your transmission power or something. Morning or afternoon, everyone, wherever you are. Morning, afternoon, evening. I'm Evan. This is my compatriot, Luke. We're here to talk to you about deploying emergency comms using FPV drones and mesh radios, so Meshtastic, Mesh Core. There's other protocols out there as well. So let's go ahead and get into it. So if the grid died tonight, if all the cell phone towers, if all the internet power in your area just went out like that, how do you either tell people where to find you or coordinate to share with your friends and family that you're okay? What do you do? Do you currently have a plan? Anything like that? Well, the good news is we've got at least something for you. So first off, who are we? Why should you trust us? To start with, we look like this. I'm Evan. I grew up in volunteer fire department in South Texas. I've been tinkering with radios and electronics since I was a little kid. My dad did it for the government, so I picked up from him. And then when I went into the military for a while, I was also doing electronics. I was a biomedical equipment technician, but it was circuit level RF theory, electronics theory, you name it. Luke?
Okay, so I kind of like a background with just ripping electronics apart. Like even as a kid, I learned how to solder like before I was like 10. Mostly taking radios apart, things with motors, seeing what I could do with them. I've been a database administrator. I've worked in operations, supply chain, procurement, cyber, vulnerability management, and before that, like I was actually on a SURF unit, which is like a chemical hazmat response unit in the National Guard, which was very high tempo. So I've had a lot of experience dealing with like FEMA and like local emergency response situations. Been through a few natural disasters where drones would have come in handy, mesh radio would have come in handy, and one where even early drones actually did come in handy for one incident, which the anniversary of was recently.
Yep. And then in addition to all of that, I am an amateur extra licensed radio operator. And if that is not enough testament to the level of weaponized autism between the two of us, both of us played EVE Online individually for at least 10 years, give or take.
Yeah, I'm
We're
actually working on a EVE Online anonymous coin to print out and bring to future conferences because I keep running into people like us.
we yep, we are in active recovery. It does get better, I promise. So this talk, this is for people who are into FPV drones, radio nerds. This is also very applicable if you're an EMCOMM or emergency communications volunteer. You can use this for business continuity. Just be very aware that there's no kind of warranty or anything for hardware when you're doing it this route. And this is also really good for community responders, whether it's a church response group or your local amateur radio like ARES, emergency operations group, anybody who wants to help the community during times of crisis. So take a seat. We're going to go ahead and dive into this. Credit to Dan, Haircut Fish, for the wonderful John Strand memes that he so lovingly blesses upon the community. So the things that we're going to talk about today, we're going to be going over how to select your drone frames, the power systems and payload mounts that you want to use. We're going to be looking at FCC Part 15 versus Part 97 for the radio side of things, and then also looking at FAA Part 107 for drone operations. We're looking at how to design mesh LoRa networks. When we say mesh LoRa networks, this can apply to both Meshtastic or Mesh Core. We'll get into the differences later. We're going to discuss how to choose and assemble your own solar-backed repeaters and handheld nodes that have GPS enabled. And then we're going to talk about executing rapid deployment, emphasizing safety and incident response coordination, or incident command coordination. Sorry. So first off, the problem that we face and some of the solutions that we have available to us. So when the grid goes out, power grid fails, you lose all your internet access, internet goes down, cell phone towers go offline. Fun fact, cell phone companies are not required to have their towers on power backups. Some of them have it, but it is purely optional. It's up to the individual provider. Some of them have gas generators, but in other places where they don't expect them to go down as often, they're just tied directly to the local grid, and that is what it is. This results in responders being blind, especially during the initial first couple of days after a very large-scale incident. Luke, you can go ahead and pick up here.
Okay, so getting into why this is kind of important, the OODA loop, we've heard about it being passed around there last couple of years, buzzword, but it is a fairly good system for thinking about most things. And most failures in action are failures during the orientation, like the orient stage, which is usually from bad observations. So in order to improve the proper orientation, you need good data, which is where radio and having a live feed that is small and in the area comes in, so the proper decisions can be made. So where this matters most is going to be in your disaster-prone areas, Tornado Alley, the Gulf Coast, hurricanes, places that already have fragile infrastructure, and
Luke, hang on a second. I think we've got an issue with your audio. Yeah. No, it's not just you guys. I hear it as well.
Okay.
Sorry, folks. Cut to the technical issues screen.
Yeah, Windows doesn't like me talking, and no matter what I do to change the settings on the gain adjustments, it keeps doing that to me. It's really annoying, especially when you're trying to run a D&D game. So where this matters, I'm guessing everyone missed the OODA loop stuff, but we can catch up on that later. The Gulf Coast, hurricanes, Tornado Alley, Appalachia with flooding, places with fragile infrastructure or prone to earthquakes like Haiti. I'm still following the earthquake down in Venezuela and other places because there are quite a few earthquakes in the past week. And this is where emergency responders and command needs the best information, the quickest to make their decisions. That way they can make the proper actions and they don't fail in the orient stage of the OODA loop.
Yep. Another place that this is heavily beneficial is in areas that are fire prone, either forest fire, flash fire, brush fires. But there is a catch to that I'll talk about later on when we start talking about RF propagation.
So dealing with communications in low energy environments, you only have so much bandwidth and power to send video, voice, and text. Text is going to be the easiest to send the baseline critical information that is needed. Video and voice are kind of luxuries and require a stable environment. So what the responders actually need are information at a location. How many people are there? What is their condition? And what resources do they have available to them? And the ability to attach GPS coordinates to put that into a mapping, like a GIS system for mapping and other data analysis. So one of the interesting things that has popped up in recent years have been drones, FPV and others, and long-range radio. So I got this off of Facebook Marketplace to demo for some upcoming villages that we were running, and you can 3D print a harness for it. Make a little.
I'm sorry, Luke. I think it's doing it again.
Yeah, somebody said check and make sure your noise suppression is turned off, Luke.
Yeah,
That's
your
not gonna
noise.
do anything.
Okay.
Yeah, turning off the noise suppression is not going to do anything. It's not that. Like it's something in Windows, and I already turned that off. So I guess I'm going to have to keep that up on a separate screen. Okay. So yeah, you can get a drone fairly cheap off of the internet, 3D print a harness, hook a little mesh radio backpack on it to get elevation, which beats a lot of the other things you need when transmitting data. And in the past few years, we've been kind of lucky to see this technology kind of democratize and spread via the open source community with everything going on in Eastern Europe.
So some of the real world deployments that we've seen for LoRa and mesh networks particularly have been focused around wildfires, hurricanes, and earthquakes, but that is not a limitation. You can do more. Your imagination is the sky. Your imagination is the limit. My brain was trying to put two sayings together. So some actual instances that we've seen in, I believe it was 2018 or 2019, a fire chief by the name of Ari DeLay in Northern California was able to push out real-time fire break or back alley road maps and fire line positions to all the crews because they had fire crews from across the state all coming together, and he was able to coordinate this information deployment out to them for a 2,000-acre blaze where they had no cell or radio coverage existing before they got there. Another instance was a separated firefighter was tracked via GPS-enabled mesh in real time, so his team was able to watch him crawl to safety without having to actually send more people in, putting more people in harm's way. But inside active fire zones, radios in general have an issue. The thermal updraft causes RF interference. And so in the case of mesh radios, people are seeing upwards of below a 68% packet delivery success rate. And it cuts your range very drastically. Where people were seeing 24 kilometers, it got cut to less than a kilometer. So you don't want to be relying on this data when you are right up against a fire, but it is good to have regardless. Just be aware of that limitation. This is something that would be of great interest to Bronwyn for sure. In other cases, and this is something that I've been talking with some landowners out in Arizona about, they had people had built a sensor mesh and they were able to detect an unauthorized fire within 30 to 60 minutes of ignition. So they were able to get fire crews out there before anybody even put a visual on the fire. So they were able to get it under control early and then get it put out. Other examples that we've seen, Hurricane Helene. Luke personally lived through that. Helene destroyed power and cell infrastructure across Western North Carolina and in Tennessee. There were local groups that rapidly deployed mesh to build their own text messaging and GPS sharing situation. And then afterwards, they decided to keep that arrangement going, and they built the Mesh AVL community in Asheville to provide permanent mesh coverage. Luke, you want to talk about the situation that you had experienced?
Hurricane Helene, yeah, I drove through it, and that night that it actually hit, I luckily didn't get stuck in it. Like I was like right on the outskirts of it, but I did talk to some people out at DEF CON who were working for a cell phone company, and they were using mesh to relay between the trucks going to get gas at different stations for like just in time delivery of keeping the generators, like the couple of cell towers running so they could have a little bit of cell coverage.
Yep. It was definitely helpful for that. Also, during Hurricane Michael, in Mexico Beach, Florida. The Texas Task Force 1 that came out to assist, they deployed GoTenna mesh across multiple agencies, and that was able to give multiple agencies the ability to perform cross-agency communication without having an existing cell or radio infrastructure because everything just got knocked out. Another interesting deployment was in, I'm not even going to attempt to say the name properly, but in that city in Turkey, there was an earthquake in 2023, and it killed over 50,000 people. Cellular infrastructure collapsed, and there was a very large amount of signal attenuation through the rubble, so cell signals were not able to get out. Students at Istanbul Medipol University developed something called LoRaQuake, which was mesh nodes that were pre-embedded in buildings before disaster, so that when buildings collapsed, the seismic triggers activated the radio network, and it enabled survivor location and two-way text communications in the areas that were affected. If you want to see more information about that, there was a presentation at IEEE ICC in 2024 for that. There you go, Luke.
So the typical workflow, how this kind of stuff works and how it's been used is the past few years, thermal scans from drones have been excellent for finding people that are lost or can't easily be seen because of rubble or weather conditions. And that location is marked, transmitted back to whoever's in command. There's been a couple of cases with lost hikers. I know one was cases out in Colorado, and the one was somewhere out in the Midwest where they actually dropped a radio down to the person. They landed the drone, person got the radio and was able to talk to who was trying to rescue them. And that allows for like the information, how many people are injured, their condition, do they have any medical needs, like they're diabetics, do they need water? And that can be used to quickly scan a large area and relay information back to rescue.
Yep. So next up, we're going to go ahead and jump into drone platforms and hardware. So this is, I'm knowledgeable about drones, but Luke is the expert on this.
So 3D printed drones, this is something that has kind of been around for a few years. I've been following drones and 3D printing stuff since around 2010. And
yep. Luke, your audio again. The good news is the audio roller coaster is preventing donations to the swear jar.
Yeah, you can't hear what I'm saying. So anyway, I've been following drones and 3D printing for years. It's been kind of niche until Ukraine popped off a few years ago. And that led to the global community online, engineers, military people, drone, like RC plane hobbyists, drone photographers, programmers, the whole assortment of nerds, kind of sharing what works, what doesn't work, designing things that aren't in a war zone. And the Ukrainians have actually developed a 6-week iteration cycle for drone manufacturing new designs. And it's kind of great that this technology, for better or worse, has democratized and gone open source. Because like even here in my office, I can print off like parts to a drone frame, and I can recycle parts out of other things to keep it together. And the good thing about this is if it breaks, you can just fix another part. Like this one here, one of the legs is going to break off. I can just 3D print out a new leg for it. And it's budget friendly, more so than designing something using aircraft grade aluminum. And it allows you to be more modular. You can pick and choose because mission dictates payload. You've got the small FPV quads that everyone's used to. You've got the long-range fixed-wing drones, which until recently, that's what everyone had in mind, like the big MQ-9 Reapers, the Ravens, the other plethora of small drones. And then you've got the utility quads, which actually interestingly enough, got to kind of play with there a few weeks ago is one of the big sprayer drones. It was on the back of a truck, but I got to look at it and kind of poke around a bit. But those are used for heavy lifting up to 80 gallons of liquid to spray on a field.
Yep. And the other benefit to 3D printing your own frames is they are easily repaired using gaff tape in the field or duct tape, whatever you got on hand.
Baling twine and super glue.
Yep. Keep a couple things at JB Weld on you.
There are multiple classification groups of UAS, which is the technical term for them in FAA regulation. We're going to be dealing with Part 107 legalities. So we're going to be dealing with Groups 2 and with Part 108 into the very bottom of Group 3, because I think Part 108 is going to allow up to 110 pounds. But these are going to be smaller systems that are going to be handheld usually, or can fit in the bed of a pickup truck as long as the mean takeoff weight's not over 55 pounds.
Yep.
So each type of drone is flight time and range and how much it can carry. That's going to be dependent on how much motor power you have, how heavy the battery is, how far you're going. A lot of this stuff, you're really not going to want to use it a great distance. You kind of ideally want to keep half of your battery life, not fly further away than 50% of your battery. In case something happens, you'll be able to return, unless it's a circumstance in which you don't care. But the fixed wing drones are going to typically have a longer range. That's probably going to be good for more wide area scanning. The small quads are going to be more useful for either setting up a radio repeater, a perch and stare drone, which that's been a common thing in Ukraine, and some state governments have been developing these. I think Britain has the Viper, which has solar panels and a bunch of radios on it, and it can actually stick to the side of a building. And then you've got the utility quads, which they're going to be short range, but that's for moving heavy objects over a short hostile terrain, like up a hill or across a gap that's been washed out.
Also, local law enforcement agencies have started adopting the smaller 5 to 7 inch quads at a much higher rate lately. They use them for things like fireworks enforcement, as well as sending the drone in to go chase somebody on foot instead of sending in officers into a potentially dangerous area, things of that nature. But we're also seeing they're starting to use drones for more mass surveillance type operations as well.
I actually saw something there the other day where I think it's out in California, where they stuck a magnet to a string on the bottom of a drone to get a knife out of a passed out guy's hand so they could go take care of him.
That's pretty smart.
These are just examples of what these drones look like. This is a standard quadcopter on the far left. In the middle, you have a Flytory Stork, which is a long-range fixed wing, though the version 2 is VTOL. And your utility quads are usually going to have 4 or 8 motors, very large motors, but they have a very short range, but they can pick up a significant amount of weight. So as I said, mission is going to dictate payload. What are you trying to do? Where are you trying to do it? And how far away are you trying to do it? Are you going to be able to easily fix it in the field, print off new parts? I've seen some organizations I've read about, they actually have trailers of 3D printers and just buckets of different electronic components to build and fix drones in the field. There's one French company that's doing it, and also the French military. They've kind of done a lot with that. I just can't remember the name of them. So how to drop payload safely with Part 107, the best thing to do is just land it and have the person retrieve it out. But you have a servo latch. Servo can either open up a door for like a little panel for people to get whatever you're delivering out, or it can drop it at a safer location that is not over top of people or damageable property, such as buildings or vehicles. And you have gravity hooks, which that's a bit simpler from the servo latch, but it essentially kind of works the same. Then you have magnetic releases, which anything that we're talking about in the modified commercial off-the-shelf drones or DIY kit bashes, you're not really going because that's
Your audio, Luke.
anyways. You're not going to be doing magnetic release stuff because it requires too much power and weight. But you'll probably be using servo latches and gravity hooks, and ideally you should land it. That way you don't get any trouble legally or hurt anyone or your drone. So when doing flight planning, you need to factor in how much battery life you're going to have. Are you flying into the wind, against the wind? If the wind is over a stiff breeze, don't really fly in it because you're going to risk a runaway unless you have a larger drone that has a bit more heft. And figure out where you're going to be dropping supplies or setting up like a radio repeater or something. Plan conservatively. That way you have enough juice to spare to make the return flight home. And battery time versus.
Yeah, sorry.
No, never mind. Like one of the big things is perch and stare drones, which it's basically its primary thing is to be a surveillance or radio repeater. Typically, where these have been used the most have been self-placing landmines, but they have found use as radio repeaters because it flies up to where it's needed and you can retrieve it by flying it down. But its main goal is not to fly, it's to rebroadcast.
Yeah. And those typically have their own solar panel attached so it can land, run whatever electronics are on board off of the battery in the solar panel, and then hopefully maybe even recharge the battery for the return flight. If you are wanting a return flight.
Which you should be.
Yep. In terms of the flight time versus battery weight, there is trade-offs. The sweet spot is currently with the existing technology we've got right now is about 400 to 500 grams in terms of battery weight. Once you start getting over that, you run into diminishing returns on how much flight time you get out of it because of the extra work that the drone needs to do to keep that extra battery mass airborne.
So, like we talked about a bit ago, thermal imaging. This is one of the other areas in emergency response that is useful. The one case, there was a boy that was missing out in the corn state somewhere, and they found him using a thermal drone, and they were able to go get him. But like police, this is how they track people, like on a foot chase or pursuit, or see where people are at in shrubbery and concealment. So the idea is to sweep the area with thermal. If there's anyone there, investigate and determine whether you need to drop a radio or anything.
Yep. So similar to what we were seeing with the thermal, just a general search and rescue operational flow. You're going to want to scan the area with, the thermal or the infrared, whatever you have, mark hotspots. If you can, descend and verify visually with the drone and mark the GPS location. If not, you might need to send somebody in on foot if you're not able to get the drone in that area safely. If you can, drop your Meshtastic unit if you carry one on the drone for delivery, and then that will enable the survivors or victims to relay messages and GPS back to incident command or your response team.
So drone operations, safety and coordination. Drones have to have the proper markings, remote ID basics to broadcast to with anyone with a ADS or anything to track aircraft. You have to have a spotter when you're flying, and you cannot fly beyond visual line of sight without a waiver, which there are exemptions and a fast track process during emergencies, especially if you're helping an emergency organization. Though with Part 108 coming out, there are going to be changes to that if you are operating under a business entity. And really, this is to keep people from cowboying. This is when people get in the way of life flights, emergency personnel, and it actually comes with a hefty fine and sometimes even jail time. One example coming up in a couple of slides. And also there's the temporary flight restriction areas. The big one's been in the news recently for the drone community has been the FIFA games. And those are flight restrictions in areas that normally wouldn't have a flight restriction, but it's because of an ongoing event, such as a disaster or soccer games. But the main thing here is if manned aircraft are in the area, you're not. Divert away from them and move out of the area. And always communicate with someone who actually has legal authority, such as the incident commander or other emergency operations support there.
Yep. So for a visual example of what a TFR looks like, this is the temporary flight restriction for the Hunt and Kerrville floods that occurred in Texas in, I believe it was 2024. The bigger circle on the left is the TFR that was centered around Hunt, which was where the biggest part of the flooding happened. And then there is a TFR that follows the Guadalupe River all the way down to the east. And then another flight restriction where the Guadalupe River dumps out into Canyon Lake, where they were also flying patterns looking for survivors or, unfortunately, deceased people at the other end of the river. So they were patrolling around Hunt. They were patrolling all the way up and down the Guadalupe River, and then they were patrolling around the mouth of Canyon Lake. This
incident here is actually the one case where a guy actually delayed a helicopter life flight because he had his drone right over top of it.
Yes. Fortunately, I don't believe there was any contact between the drone and the helicopter, but it grounded that helicopter for a while until they got the drone out of the way.
And he did get fined a substantial amount. It was in the tens of thousands.
Yeah. And another example of a TFR that is a lot more common, happens all the time, and this is the one that you do not want to mess with because you will get fighter jets intercepted to your location, is a presidential TFR. This is an example of a TFR that is focused on Mar-a-Lago. I pulled one from, I think this was from January. But what you have here, the inner circle is 10 nautical miles. You cannot go in there unless you have previous clearance, or if you are a TSA cleared air travel. So, for example, airliners and whatnot, they can fly through a TFR like that with the intent to get to their destination. But private aircraft, because you're not going through TSA at the general aviation terminal, you can't unless you specifically coordinate clearance. And then the larger ring around it, so long as you are squawking a certain code and you are in contact with air traffic control the entire time, you may transit through so long as you are not flying towards the inner ring. And again, you bust this one and you get very, very big trouble. Typically, you get F-16s sent to intercept you. So moving on to the radio side of things. So first off, what is LoRa? So LoRa stands for long range radio. There are several different protocols that use LoRa. The main two that we're going to be talking about today are Meshtastic and MeshCore. There's some pros and cons and differences between the two. But at its heart, LoRa is an open source, encryption capable mesh networking radio technology. There is no license required for it. However, the radio that LoRa transmits on is a proprietary radio owned by a French company. So the protocol is open source. The radio itself is not. It is a low power wide area network, and it's designed for long distance, low data communication. There is a radio that has been released recently that is intended to give you like a 3G cellular voice level of communication, but I have not gotten my hands on one to test that out yet. Typically, you're going to get 3 to 6 miles of range for a handheld device like this one here, but it can be relayed further, and you can get further if you're using repeaters, things of that nature. But this technology gives you text and GPS at roughly $30 to $90 per device for a handheld. But a lot of this technology, a lot of the hardware is coming in from overseas, so tariffs are going to apply. So be gracious with that pricing. Some of the proven hardware that's really good to get started with. LilyGo has the T-Beam and the T-Deck. This is an example of a T-Deck. This is in a form factor that is basically a blackberry, other fruit. Similar to a BlackBerry, so it's really easy for people to pick up. The T-Beam is just a board. Heltec makes an ESP32 LoRa board as well, and then SenseCap makes the P1, which I have for here. So this is a SenseCap P1. This is a repeater, and then they also make the SenseCap T1000E, which Luke had earlier. It was that little credit card looking radio tracker. Yep, that one right there. And LoRa has been seeing a resurgence of heartland adoption. A lot of people are using them for rural off-grid resilience. Last year, there was a really big trend about people starting to put them in their family bug-out bags and people building community emergency nets like what we're talking about today. So Meshtastic versus MeshCore. So we're going to start off with Meshtastic. Some of the pros that it has, it is a true mesh. All the devices relay, which also means it's self-healing. If you have a radio drop out of the mesh, the rest of the mesh doesn't care. It just continues to chug right on ahead. If you fire up a new mesh, so long as your settings are correct, it just joins the mesh with everybody else, and you're about, up and about, which allows you to build flexible and ad hoc networks. You do not need to have pre-existing infrastructure to run Meshtastic. Some of the downsides to that is it has a limited amount of hops. I believe the default is 3. Currently, the max is 7 times that the message can be relayed. And you have higher network congestion, and you can start running into network instability once you have more than 50 nodes or so in the area. This is because since all devices are relaying, this works more like a level 1 switch. Hub, sorry, where it's just shouting into the ether, and then everybody else that hears it shouts it as well. So you start getting a lot of duplicate messages floating around. Also, Meshtastic does not have any kind of a delivery status mechanism, so your message delivery is ambiguous. You just yell, and if somebody else hears you, they hear you, but you don't know. On the other hand, we have MeshCore. So some of the pros for it, you get extended range. You can get up to 64 hops, and you get lower network congestion. Also, MeshCore can give you a delivery confirmation. But the downside to getting those pros is it requires repeater infrastructure because only the repeaters can relay the messages. Your handheld nodes can't. So handheld node sends it to the repeater, and then repeaters send it out much like a regular switched network. But this means that you need fixed network planning. The good news is you can run both at the same time. There is enough space in the 915 megahertz ISM band where you can run on different channels, so there's no interference there. And so long as you have some vertical separation, you can even run antennas for each one off of the same pole or tower or wherever you're doing. Just get your antennas spaced out a little bit and then run non-overlapping frequencies, and you can run both. There is also some projects on GitHub that are working on bridging the two protocols, so you can have Meshtastic devices like in town, and then you can use MeshCore to connect to a multi-county repeater backbone. So you get some of the benefits of both. I have not had a chance to get any any hands-on experience with that yet, so your mileage may vary. I can't endorse it, but it is an interesting concept. Bandicoto said, yo, 350 Meshtastic nodes at the Daytona Hamvention this year. That's awesome. Okay. Yeah, that is fantastic. I do know that there's also a very large mesh node that happens at DEF CON. And then I will be hosting a mesh network at Deadwood this year as well. I'll be bringing my repeater and antenna. So we'll be getting that set up. So for licensing on Meshtastic or Mesh Core, so typically you operate under FCC Part 15, which is unlicensed devices. You do not need a license. You do not need to file anything with the FCC. You can buy your device as soon as you get it in from the mail. You can slap the battery in, fire it up, and you can also turn around and just hand it to a response volunteer or a survivor, and you don't have to worry about any paperwork involved. Constraints by using it on the unlicensed side, you do have power limits. So you're subject to being under 30 dBm or 1 watt in the ISM band. That comes with duty cycle limits, and you have to stick on the frequency bands. So here in North America, we're 915 megahertz. In Europe and Asia, they are 433 and 868. I think I got those in the correct order, but I forget. And you also don't need an ID, so that cuts both ways. Not only do you not need an ID to transmit, but also now anybody else who might be interfering with your transmissions, you don't know who they are because they don't need an ID either. So the best use case for Part 15 is going to be your handheld nodes that you give out to victims and the gear that you distribute to volunteer responders. But if you need more power, then you can step up to FCC Part 97. Part 97 gives you access to a higher power level, technically up to 1,500 watts of peak envelope power. I have a very unhealthy desire to see a mesh radio running at 1,500 watts just for the sheer ridiculousness of it. But in order to do this, you need to have a license, technician class at least at a minimum, and then you have to be transmitting your call sign at least every 10 minutes. Also, if you are operating under Part 97, you are not allowed to use encryption or use it for commercial use. In best case for this, use it for a repeater backbone. If you've got any Part 97 licensed people in your organization, you can use them to run this, or you can reach out to your local Aries or Races volunteers. If you don't have any, find the local ham club. They're always happy to help in terms of disaster recovery and response and community assistance, things of that nature. Just remember, again, Part 97 means no encryption and no payment is allowed. So when you're sitting down to determine what you want to do, figure out what you want to use for both sides of the operation and plan accordingly. So node types are going to be dependent on your mission. So in general, you have 3 different node types. You have a handheld node, you have a repeater, it can be solar powered, it could not, and then you can have an airborne node or a vehicle borne of some form. If you've got an RC car, you can strap a mesh node onto it and go do that. It doesn't necessarily have to be a flying drone.
And one note on the airborne nodes, the one thing that a lot of people have brought up at some of the conferences have been balloons or aerostats. Those actually, I believe, fall under Part 101, and they have to be tethered, but they're a lot easier to maintain a power line to. It's just an extension cord going to the radio equipment.
Right. Some commercial off-the-shelf nodes. I have gotten my hands on all of these. These are all ones that I have used personally. In fact, half of them I currently have sitting next to me. So for a handheld node, one really good option just to get up and running is a LilyGo TDEC Plus. This is the one I have. I recommend getting the version that has the external antenna connection. Typically, these are about $80 to $90 for the Plus. And then there are 3D printable back cases that allow you to cram I believe it's an 8,000 milliamp hour battery in the back of it. It's either 5 or 8, I forget. For a lot better extended operation time. Additionally, the LilyGo T Echo is a very small device. those are really good for attaching to environmental sensors, things of that nature. If you want to put temperature sensors down on the ground and measure if the temperature at the ground level rises as an indication of a flash fire or anything like that, or if you want to hook these up to water level readers or anything like that. Some really good repeaters. I'm so sorry. The Rack Wireless WizMesh Repeater Mini is about $110. That's a really good option. Also, the SenseCap Solar Node P1, you can either get the base model for about $70 or you can get the P1 Pro, which has built-in batteries and GPS for right about $100. The one that I have, this is the P1 Pro. It's about yay big for reference, and this one is IP. I forget if it's IP67 or IP65, but it is fairly well weatherized. If you want to build your own, however, the breakdown of what you're probably going to need, I would recommend getting an ESP32S3. You can get yourself an OLED display. The SX1262 is the LoRa radio chip itself. And then if you want GPS, you can use a Neo 6M or a Neo M8N. And then you can run these things off of 18650 batteries all day long. They work great. But I do recommend trying to, M. Spartacus made a good point. I do recommend getting a BMS, but if you just have a separate charger for the 18650, you can just slap it in here and change it out. And then you're going to need some form of an antenna. You can get a spring or a rubber duck antenna, something as large as this, or just the small little rubber duck antenna that comes with this. And when I first built these slides back in January, this was about $52 per node. Part prices change very frequently, so take that with a grain of salt. But if you're going to be having it out in the weather, I do highly recommend building a ruggedized node. So you can get IP65 or 67 off-the-shelf boxes. You can 3D print your own shells if you want to. And then you can buy gasket or O-rings, or you could even 3D print your own at a TPU. If you have cables coming in and out, you can run cable glands for antenna and power, throw a couple desiccant packs inside, and if you're in a place that sees any kind of pressure deviation, throw in a vent plug. That way you prevent the chance of maybe your gasket blowing out. Some of the environmental challenges that you're probably going to face if you're down here on the Gulf Coast like I am, heat and humidity is a killer. If you're in Appalachia, heat and humidity during the summer and cold and wet in the winter. And then also, if you have your devices outdoors, you also need to be factoring in UV exposure, especially if it's on a tower or on a rooftop somewhere. If you're really worried about it, build yourself a sweat box that you can test these in before you throw them up on a radio tower for a real deployment, if this is going to be something that you want lives to possibly depend on. For power budgeting, this is very general, so sit down and run your own numbers for each build that you've got. But power budget example, if you're using a Rack 19007 and a Rack 4631 LoRa module, those typically draw about 250 milliamp hour across the day. A good solution for this, you can use about a 5 to 6 watt solar panel with 3000 milliamp hours worth of 18650 batteries. And definitely, if you are going to be running any kind of charging solution, get a battery management solution, a BMS. Don't just connect straight up, because that is a potential fire hazard. If you want these to be autonomous, try to plan for about 5 to 7 days of battery autonomy without having any kind of solar charging coming. And plan the battery type that you've got on the mission. So LiFePO4 batteries are going to have a longer cycle life and are safer, but lithium-ion batteries are going to be lighter and have a higher energy density. So lithium-ion is going to be better for your drone-mounted stuff, and LiFePO is going to be better for things that are going to be hard installations, especially if you are in an area where it's fire-prone. Be very, very careful about that, because you don't want to be the cause of a forest fire. Yeah, lithium ion fires are definitely a sight to see. The old Samsung Notes for sure.
Yeah, they're not fun to deal with either, especially when you throw one out the window.
Yeah.
Get
So
mad with smoke.
yeah. So in terms of getting your signal out there, elevation is going to beat transmit power every day. It is more beneficial in every metric than just cranking up the transmit power. Trees, buildings, your natural landscaping is going to eat RF more than just the raw distance that you're trying to transmit over. And so height ends up mattering exponentially more than your transmit power. If you're in an area with flat terrain, like some areas of Texas, Tornado Alley, that has few high points, you can use balloons or kites even, or you can do drone delivered rooftop nodes, and you'll have more of a wide open line of sight. Yeah, as Bandicoot just said, height is king. For places like Appalachia or Haiti or other areas where you have a lot of mountainous terrain with a lot of elevation deviation, put your nodes on top of ridges and passes. Try not to put them deep down in the valley because it makes it a lot harder for your signal to get up and out. If you are trying to get quick gains, you can use arborist lines to throw your radios up into tall trees. You can talk to churches, put them up in steeples, put them up on flagpoles, so long as there's not lightning going on in the area. And then you could even use the perch drone as a pop-up relay. Yes, and a correct antenna is number 2. So the reason why height works out as being king is because of RF propagation being blocked by terrain and structures, as well as something called the Fresnel zone, which involves a lot of math. So I'm not going to get deep into the math on it, but just to give you an idea, the Fresnel zone is a football-shaped field of emissions between your transmitting radio and the destination or end node. The formula for it is 8 point blah blah blah, that right there. So if you want to take a screenshot, go for it. If you want to just Google the Fresnel zone, go for that. But the rule of thumb is for you to have unimpeded transmission, you want at least 60% of the Fresnel zone to be above whatever your highest obstruction is going to be. And so the way that you figure that is you run the Fresnel zone calculation, do it in metric. It's a lot easier, and the formula is set up for metric. And then whatever your 60% is going to be, add that to whatever the highest obstruction between you and where you're trying to talk to is, and that'll tell you how high you need to try to get your antenna. Now, you can still communicate without being able to get a fully clear Fresnel zone. This is just to get the most efficiency out of your transmission. So if you can't get up to a clear Fresnel zone, don't worry about it. Just do what you can. Do the best you can. Antenna selection. So first off, I'm going to start with the rubber duck. This is a rubber duck here. They are omnidirectional. They have about -2 to 0 decibels worth of gain, and they're great for flexible portable nodes, handhelds, stuff like that. Whip radios are slightly longer. This is an example of a whip radio or a whip antenna. These do offer a slight bit of gain, typically around 2 to 4. They're great for ground or vehicle installations or handheld nodes where you can have that extra length. Yagi antennas, if you think the older radio antenna, or sorry, TV antennas that have the spikes coming off the side, they're directional and they're good for long distance links and for repeaters that are specifically talking between each other. Those are going to be 8 to 12 dBi or higher. Helical or spring antennas, you're typically not going to see. They're compact or embedded. A lot of times they're inside the case of a radio. Those do have a small amount of dB gain. And then also bear in mind your coax discipline. You want to keep your coax as short as possible if you do have a coax line running up to an antenna, because every meter of coax is going to be more signal loss. So when you get your antenna and the coax up in there, you're going to want to make sure that you're verifying that your signal noise ratio and your RSSI numbers look good. And yes, Bandicoot makes a good point. TV antennas are typically log periodic. They're not Yagis. You can make a cheap Yagi out of a paint stick, or a paint stirrer, and pieces of tape measure if you're on a real budget. In fact, DEF CON and some of the other conferences, they have contests to see what's the most creative antenna somebody can make and talk off of. Another way to explain antenna gain, if you think about those kind of flashlights where you move the lens in and out, up and down to focus the beam, the more focused your beam is pointing forward, if you're walking at night, you're not going to be getting light down on the ground where your feet are. So for the higher dB gain on an antenna, the more focused your beam is going to be in a certain direction, and you're not going to get reception outside of that. So for planning and deployment, some of the things that you want to take into consideration for that, first off, you want to make sure you're planning in blue skies. Plan while there's not an emergency going on. Figure out where your high-risk areas are. Pre-plan your infrastructure with permission. If you have local businesses or churches that are giving you permission to put radio antennas somewhere, talk to your county emergency coordinator. You might even be able to get permission to put a mesh node on top of a water tower or something like that. Map out your candidate repeater sites and stage your replacement gear nearby. Set up channel and naming conventions. So you want to have naming conventions that make sense to people who join the op, right? You don't want to have super cryptic names or names that just don't mean anything to somebody who's not in the know. Keep a printed set of your maps and laminate them if you can, as well as cheat sheets, your handheld checklist, whatever troubleshooting you have set up steps, things like that. Run tabletops. Do field day drills. Practice. Don't let the response operation be the first time that you're putting hands on the radios or putting your plans into action, right? Just like with cybersecurity, you want to be practicing beforehand. And then after action reviews. If you've got something that happened that, oh, hey, this is a problem, we need to work on doing this a different way, you can. Yeah, backdoors and hurricanes. There you go. Also,
Okay. I think we just got like a 2-minute warning if you want to.
Go ahead and blaze through. So just be aware that you need to have a realistic timeline for getting something like this set up and running. It's not going to happen just overnight. Some additional case studies are here at the end of the slides. The slides have been provided in the slide resources channel just below live event chat, going over Oklahoma and Haiti, as well as a rough cost breakdown of what you're going to spend to get a small set of this equipment up and running. Real quick, things that this cannot do. This is not going to replace an official search and rescue or aviation op. This is not going to guarantee message delivery, especially if you're just running Meshtastic. And again, this is not going to work without planning and maintenance. Some of the technical risks that you're going to run into are RF interference, node failures, and the potential for GPS inaccuracy in canyons, cities, deep valleys, things of that nature. And operational risks, poor incident command coordination. Drones are a hazard to manned aircraft and to personnel. And then just always assume that either gear theft or misuse is going to be a thing. So assume some nodes are going to die, some links are going to fail, some drones are going to crash. Build in redundancy and plan for graceful degradation. And that's what we've got.
Awesome. Nicely done. Kevin,
Sorry about
bring us back to the fold. That's all right. We got it in. We got under the wire. Now we're going to do some questions. So there is a lot of questions. You probably saw us gathering some here on the back end of Zoom for us, and then we've got some in our Q&A. So Maddie and Connor are here to help us tackle some of these questions. And
yeah, I can grab a couple from Zoom right now. Some of these,
if you got one ready to go, fire away.
Yeah.
Sure, yeah. So what materials do you suggest for 3D printed drone parts? I mean, like considering ABS, PLA, some of the kind of more common ones.
The one that I am coming to rather enjoy before the input gain attacks me again is just PLA Aero, and you glass it with carbon fiber and epoxy. You have PETG, or just printing an ASA, which when you're printing an ASAs or ASA Aero, do not do it inside your house or a area that is not well ventilated. It is also a huge PETA to dial in and get it right. And it's also really expensive. So I'm going to recommend just a regular carbon fiber or just lightweight PLA, and look up some videos on like how to glass it. It's one thing I picked up from like the radio controlled hobby plane community.
Yep.
Cool.
There's also
Yeah.
lightweight PLA, lightweight PETG, and then you can even get PETG that's pre-impregnated with carbon fiber if your printer nozzle can handle it.
Now, I'm still pretty much of a novice when it comes to 3D printing, but is lightweight PLA and like because I see sometimes like when you buy PLA, there's an option buy PLA plus. Is that similar? Is that the same as lightweight PLA or?
PLA
No.
Plus is just stronger. PLA, lightweight PLA is like usually foamed or pre-foamed. It's it's a lot lighter. Like
Gotcha.
one thing, like think about it's going to be the stability of the airframe. Like, is it going to be able to handle the motors, the vibrations and impacts? Really, when you crash any kind of thing flying, it's going to get smashed up.
Yeah, that's kind of a law, basically the law of physics there, pretty much. But
It's like what I said. Like the limitations with drones, it's human imagination, the laws of physics, and you can't really beat physics.
exactly. So another question that kind of lines right up with it is somebody's asking like, where do we find 3D printable models and accessories for drones? So he's asking if there's somewhere standard or there's specialty groups. I mean, I think there's probably an answer that
Flight Tory, I really like Flight Tory's models they put out. They're affordable, they're well built. I believe they're European based. And just look up flytory.com. There's a lot of drones on Thingiverse. Colts 3D has a lot of drones on there, but kind of be wary and kind of look into the reviews and any preview parts they might have for download, because they can be kind of expensive and maybe of a not great quality. And I just saw one here about adapting flat cut FPV frames. That's also doable. Like I've seen people make drones out of PVC pipe, taking a carbon fiber plate and cutting it out with like a CNC router or something like that.
Yep.
Oh no.
But yeah, no, that's viable. You don't have to 3D print everything. I like to see how far I can get with 3D printing, though. Like the orange thing next to the bagpipes is actually a 3D printed drone.
Nice. Nice both ways, both the orange and the bagpipe. Both very cool. Now, so the other question I got is somebody was asking is what low-cost quadcopters are still sold in the US that you would recommend, and one that isn't banned by the US government.
Well, the DJI stuff, like that's only banned for federal and state use. Like if you're part of a government organization, you can't use one of these, which this is a Gen 1 Mavic Pro that I got for a couple $100 off of the internet. Still works. You can 3D print parts for it. There's already like a catalog of people who've already designed stuff. So an older DJI, you can still fly it. The ban right now, as my understanding, it's you can't use DJI for infrastructure or state and federal projects.
Yeah, that's my understanding as well.
There are other companies that make drones, like Parrot has some, GoPro even has some, and there's a community around building like clones of like your common off-the-shelf drone.
Yeah. I think Darwin also makes small FPV drones. I think it's called the Baby Ape. And it's like a 3-inch drone. I think they're about $125, something like that.
Interesting. Yeah, I don't think I've heard of that. That's pretty cool. Maddie, did you want to grab some questions from the Discord? Because I'm pulling from the Q&A right now. Is there any that you wanted to kind of? Oh, I actually see them in the chat here.
And
I can.
Doug Ford also mentioned that the Potensic Atom series is a good call out as well. They're a good budget option.
Nice. Okay, and then actually somebody was asking, so in the chat, if you're willing to be a little more hands-on and solder the components yourself and stuff like that, are you saving a lot of money, or are these
Yes.
you are saving a lot of money? Okay.
Like I see like pre-soldered components on like Amazon and like eBay and other sites. And they're usually what I would consider grotesquely marked up for how simple it is to usually solder like a piece onto like a speed controller or something. For the each individual motor has a thing called a speed controller. It's how it communicates with the flight controller. And you'll see them like $20 more expensive for like pre-soldered, in some cases as high as like $50 more.
Oh,
And
yeah.
it's cheaper just to get the components and solder it yourself.
It is.
Yeah, that's pretty cool. Now, soldering I can do. Desoldering I cannot do. Once I got it on there, I am absolutely horrible at getting a component off. It becomes a terrible mess.
For desoldering, hang on, I'm grabbing something. I highly recommend you go on Amazon and you get yourself what is called a solder sucker, like this.
That's a fun name.
It really is. It's just a tube with a thumb actuated plunger and then a button, and all it does is just draws suction through this. So you get your solder heated up and melted, and then you prime this, hold it up against the solder, push the button, and it sucks all the solder away from the joint. It is fantastic, and one of these on Amazon is $15, I think.
Can you reuse the solder after that? I don't solder stuff, so this might be a rookie question.
Yep, it's just metal. You just reheat it.
Yeah, that's what I figured.
Yeah, you can definitely reuse solder. But solder is cheap enough to where it's not really, you're not gaining that much by doing it, to be honest. But if you're really in the need on, out in the field or something, you can reuse it if you can capture it.
Or you just want to challenge yourself, because I can't think of any need where I would even try that.
Right. Also, in regards to the question about saving money if you solder all the components, or I'm just going to take that a step further, if you just build your own, handheld radio out of individual components, stuff like that, there are companies that do offer fully built stuff that is more aimed specifically at a certain niche market. And I'll go ahead and float one of the names out there. They are Spec 5. They offer basically what is this. So this was, again, $80-$90 for one of these. Or, no, sorry, $50-$60. They offer the same thing, but for $180. They add in a couple of extra features, a couple of extra pieces of hardware, and then their own 3D printed shell. So in that case, typically you're paying for their proprietary version of whatever the operating system is on it and their own 3D printed case design, and that's it. So I'm not saying they are bad products. I'm just saying if you want to pay that extra for those features, cool, go for it. But you do not need to.
Gotcha. Yeah, that makes sense. Actually, we've got somebody asking, what is the best hardware for tinkering around with Meshtastic plus LoRa?
So
in my area, I don't know what area, but just I guess in general.
Yeah. So if you are wanting to just get straight into the usage of the Meshtastic itself, you get yourself, something handheld like a Liligo T-Deck. If you're wanting to have your own repeater, you get yourself like the SenseCap P1 or the Rock Wireless WizMesh, something like that. Those are going to be plug and play, fire them up, and you're off to the races in terms of using the radio itself. If you want to do the tinkering of building your own stuff, Rock Wireless makes really good base boards to start building on top of. So does SenseCap. Heltec also makes really good stuff. There's a lot of community support for all three options. So just, pick one and start. Typically those boards are going to be cheap. They're going to be in the, I think, $20 to $30 range. And then it's a lot like building with a Raspberry Pi. You know, you've got your headers and other open source hardware options.
Yeah, you talk about the Raspberry Pi, like on the direct side of things, like you get into like Raspberry Pi flight controllers. I've seen some people doing that. I've been reading a lot into like companion computers for like the Orange Cube, which I have an Orange Cube flight controller, as well as a Raspberry Pi 5 with a headless LTE modem on it, like kind of figuring out what can be done there. I'm just looking at some of the comments here.
Got you. Yeah. No, that's interesting. I knew that there were people were making there's a pretty good amount of people who are trying to build adapters for that with Raspberry Pi to kind of make it very plug and play. I've seen kits for that, but I've never played around with that with a Raspberry Pi. So yeah, that would be something new for me to kind of play around with. But very interesting nonetheless. The part that I was the most fascinated with was the 3D printing. Because yeah,
It's
I
a
think,
lot of fun.
yeah, I've got a 3D printer here. I don't use it for much. So I'm trying to find good use for it, and this seems like a really, really cool use for it.
Yeah. Oh, definitely. And 3D printing is one of those things where you can spend hours just rabbit holing and figuring out how to optimize your prints and everything. It's its own thing.
Yeah, this is a 3D printed Flytory model. It's the Stallion VTOL.
Cool.
Yeah, that's
pretty
all.
big.
Yeah, and this isn't even one of the bigger model file sets I have. I have one.
We lost you. Your audio dipped again.
Yeah, because the owls don't want you to hear me, but like this is actually not even one of the bigger airframe 3D printed model sets I have. I have some that are considerably bigger. You can also scale these up whenever I get workshop space after I'm done moving. I'm going to try to get into actually carbon fiber molding and basically making an inverted model and layering it with carbon fiber and doing a vacuum epoxy on it.
We've actually got a question kind of a follow-up question from someone in the chat, but this is actually kind of what I was thinking too, because we were talking about Raspberry Pis, but can we easily use ESP32, or do you need more advanced hardware for something like Meshtastic?
For Meshtastic or for with drones?
I think it's related. It doesn't say.
I see. I see the original question from Hot Plate. They're talking about with drones.
With drones, okay. Are there controllers out there that work with ESP32 fairly easily, or?
I've read where some people have done something with that, but I haven't.
Oh, Luca,
you dropped again.
Something.
It just loves to dip your audio.
I read about some people trying to do something with ESP32, but I haven't tried anything with that personally, and I'll need to read more into that. Like that's not something I really know that much about.
Yeah, I think to my understanding, ESP32 in terms of hardware capability is well above what you typically need to operate a drone. And so you're going to be consuming a lot more battery source for not a whole lot of extra gain. So you can use ESP32, but like Dogport said, I would probably just start with either an all-in-one or a flight controller and ESC stack, and then go from there.
Yeah, that's what I would recommend too.
The TBS Lucid that they linked, that's a really good option. There's other really good all-in-one controllers as well. Makes it really easy. All your control is just in one specific chip instead of having to hack together stuff on top of the ESP32.
Got you. Yeah, that makes it. I mean, maybe if you've got an ESP32 sticking around and like you had to build a drone, you just had to build one. I mean, you could, but yeah, I do agree with you, Evan. That's a lot of power output. It's sucking up a lot for that. I mean, that it's like I'd imagine somebody used like an Arduino Uno for that, or like a Raspberry Pi in the place. Right. Like I can get the job done for sure, but a lot there. And actually, we've got another question here. Recommendations for 3D printers. What are your guys' recommendations for that? I'm also curious for this.
I like the
The
bamboo
big ones.
Yeah, it's really just about the print space you use. I use Orca Slicer, which is a fork off of Bamboo Labs Studios. Prusa, they're good printers. I've had them before, but just kind of lately, Bamboo and like a few other brands kind of like leapfrogged them. Like Prusa kind of leapfrogged them, and then they got leapfrogged. So they'll, they're all right printers. It really is just about how much space you have.
Yeah.
Like I have a P1S. I wish I had gotten the enterprise version. I think that was like the 1XC or something, or the I think now the H2D is the best one Bamboo has. Evan has a really good Creality.
I also have the Qidi, a QIDI, a Qidi Q2. It's basically a Bamboo clone, but it doesn't have some of the monitoring.
How often are you guys buying new printers? How
I'm
fast is this technology moving?
The technology moves faster than my wallet does. So I think the one that I'm using right now is the second FDM filament printer that I have bought. I started off with an original Ender 3.
Yep, that was my first.
Yep. And then I've discovered the limitations of what is considered a bed slinging printer, and so I moved to a Core XY style printer, which is what Bamboo and Qidi and those, they are internally stable. So even if the printer gets bopped around, the structure is so rigid that the print nozzle won't move in relation to the bed.
Oh, see,
Would you ever buy
that's the issue I ran into. Oh, sorry, go ahead, Ryan.
Would you ever buy a used printer? Is there a used printer market?
There is definitely.
There's definitely a used printer market because a lot of people got them for like Christmas or as a gift and then didn't do anything with them. I actually got a CNC for like next to nothing. I traded like one of my old microphones for it, and the woman that sold it, she was just like, "Yeah, I don't know why I got this. I used it 3 times, and like I don't need it." And I'm like, "Okay, good deal for me."
Yeah.
I offered her more money, but there are a lot of 3D printers out there, but I would recommend like doing a maintenance check on it, like if it's off Facebook Marketplace or a flea market or something like you go to in person. I would definitely do like a maintenance check on it before you do anything else.
If you're, this is going down that rabbit hole a little bit, but if you were to buy a used printer, what are you looking for to make sure that it's functioning properly? Maintenance check, just like a function in the printer that you say, like, inkjets, they have inkjet tests to like check the nozzles and see if they're printing like
just an XYZ cube. You can go in depending on the model and check how many print.
Oh shoot, look you.
And we lost you again.
Yeah, so like Luke was saying, you can have especially if the person is able to kick off a print while you're there picking it up, print an XYZ cube. It's going to be a calibration cube. You check the diameters. They're all, I think, 10 millimeter or the 10 centimeters, something like that, but it's a set dimension. And then also another way you could test is, have them print a benchy on it, BENCHY.
I was about to say that. I was about to say, you think it works? Yeah, it works. Okay, print me a 3D benchy.
Yeah, I would assume that a printer has issues unless you are able to confirm a print just came off of it recently or in front of you.
Yeah.
Good to know. Good tips.
I just saw one question here. Has emergency management started using fiber optic links to control drones like they have in Ukraine to avoid interference? To my knowledge, I know the FBI was playing with it last year. That was in the news, but that's mostly because they are in an electronic warfare environment where radio signals are being jammed. So fiber optics the easiest go-to.
Yeah.
I know Mexican drug cartels are now using fiber optic drones, though, to keep from being tracked by border enforcement. I think the last statistic I saw is like 365 detected drone incursions across the southern border from Mexico daily. And most of them are just flying drug mules. And there's an interesting book that I'll pull up here in a bit. People might like to read because a lot of the stuff that we attribute to like Ukraine and ISIS, Mexican drug cartels have been using drones for years.
Yep. So Luke, actually, to add to that, my uncle served as a ranger. He was an army ranger for a pretty long time, but he somehow ended up attached to also like a Green Beret unit where he was kind of fighting some of the cartel. And he actually told me something interesting, which he was like, a lot of people think that the cartel, they think of them like gangsters. Like he goes, they are incredibly organized and they will use and utilize like technology you wouldn't think that most people don't think that they have. He's like, they use a lot of our own training. They use a lot of our own technology right back at us.
Just read about the history of the Zetas. And they were
oh, shoot, Luke, you
dropped again.
Oh, yeah.
Yeah, you said read about the history of who?
The Zetas.
The Zetas. They were trained at Fort Benning. They were elite, like counter cartel soldiers, and they just became a cartel. And now you have, I guess, the new Hosico Next Generation Gulf Cartel, and their drone operators are really good. The book that I actually read a lot of this on is the Criminal Drone Evolution, Cartel Weaponization of Aerial IEDs by Robert Bunker and John P. Sullivan. Actually, a very interesting book on a lot of the DIY drones south of the border that they've been using. But they've been, I think back in December, around Christmas, they actually had the first detected cross-border fiber optic drone to keep from being tracked. Because that's how a lot of the drug mule drones are getting like intercepted. Is radio.
Rookie question. A fiber optic drone, how does that work? Is there an actual fiber optic tether to this drone?
Yes. There's a translator module. I can't remember what it's called right off. It's an adapter. It's an adapter module that plugs into the flight controller, and you plug in a fiber optic cable, and these can be up to 40 kilometers or more, and it goes back to the actual handheld.
Yep. In fact, I'm putting an image in. Whoop, wrong one. An image in live event chat of what that looks like. Currently, for us pricing, it's about $3,000 for a 40-kilometer canister.
But luckily you can 3D print these for a lot cheaper. But yeah, like with the remote control, there'd be an adapter that plugs in here to the adapter that goes into the start of the thread connected to the drone, and that's how it's controlled instead of radio.
Yeah.
So if that tether gets
cut or broken, a drop.
The drone just doesn't return home. It's
most of the drones that have a fiber optic line to them are not intended to return home because they're usually a bomb.
Oh yeah, okay. So no,
it comes back. That's a problem.
It comes back.
It's like I can almost see that like a Looney Tunes, like old school Looney Tunes cartoon. Sends out the drone and it flies back. Like, no.
Yeah. In most cases, if this fiber optic line gets cut while the drone is in transit, it's just going to continue on using the last set of inputs it was given and run until it either hits the ground and crashes, or crashes in
Runs
general.
out of power.
Runs out of battery. Yeah.
And some of the drones in Ukraine, they have like a little rudimentary AI module that's like pre-programmed with like the shape files for like a T-70 tank or something. And it's like, in lack of standing orders, find a tank and crash into it, or find X, Y, or Z and fly into it.
Sometimes they're putting like a Jetson Nano on these drones, stuff like that. So they have optical recognition, stuff like that. But as Dogport said, these fiber canisters are a one-time use thing because it's dropping this really small fiber line over however many miles or kilometers. And it's not being used in emergency management right now because of the massive environmental and humanitarian hazard that they are, because these fiber optics, it's like really, really thin monofilament fishing line. You can easily cut yourself on it if you use it the wrong way.
There are birds building nests out of it, and there are pictures. It looks like spider webs over the trees in like the morning dew.
That's crazy.
Also, in terms of the 3D printing, TX Jaeger mentioned something that I wanted to emphasize. It is very worth checking your local public library, and also check to see if you have a local makerspace, because most makerspaces have 3D printers. If you don't have one and you want to get your feet wet with trying it, look into your local makerspace first before you actually make the $300-$400 or more investment into a 3D printer.
Yeah, I'm going to add on top of that. If any of you guys are in college still, a lot, and I mean a lot. And I transferred across 2 different community colleges and then university. All 3 had a 3D printing makerspace. And if they don't have it, you can even ask your school about it. Somebody got a bunch of people together from the engineering side of the school, and they petitioned their community college to just buy a couple of 3D printers for them, and they did. So I recommend checking that.
You wander around the engineering department halls and go, man, I wish there was somebody who could teach me about 3D printing, and you will get swarmed.
Yes, absolutely. Yeah, that it works great. And also, if you personal recommendation, if you want to get started with 3D printing, and this is what I was told, I don't know what you guys, but I was advised to get an Ender 3 as the start.
Okay, because I advised you for that, I think.
Yeah.
Yeah, yeah, I think you might have mentioned it as well. But you get to learn a lot about 3D printing through that, because if you buy it, you put it together at the start. And so
I had one of the first gen Ender 3s that came out, and you had to manually calibrate it with like a piece of receipt paper for every one of the points, and he had to do everything. I gave it to a friend in the community. He asked me, he's like, "Oh, how much do you want from?" I'm like, "Dude, just pay for shipping, because I'm going to feel bad for what you're going to go through, but you're going to appreciate any 3D printer after this thing because you're going to torture yourself, because it's like, oh, it's time to solve the jigsaw puzzle again before I print something. Oh, it might catch on fire."
Exactly. It reminds me of, like, I don't know if any of you guys, like, if everybody's gonna relate to this, but I remember I had a professor when we were learning calculus, and he made you do like these derivatives by hand, and there was like, it takes a whole page, and then in the second week he goes, "Okay, and here's the shortcut. Just subtract this by 1."
You got to know what you're doing.
Yeah, but he was like, "I made you go through that because I wanted you to understand why we can do the shortcut." And that's a very similar approach to the 3D. When you enter with an Ender 3 into the makerspace, you're going to learn about 3D printing kind of the harder way. And then when you get those automated features that you're paying extra for, you're going to appreciate it a lot more, because you understand what it's calculating, what you used to do by hand. So it's a good way to get started. So
the Ender 3 might be the most hacker friendly printer, in my opinion, because it was like one of the first ones that came out, especially the older gens, like all the different ROMs and stuff you can flash, and all the different parts and modifications. It's almost infinite.
I will make one additional recommendation. If you get yourself an Ender 3, number one, go into it with the understanding that you are going to have to work to get it to print well. Part of the process is learning what all the settings do and what changes what, things of that nature. But also look at buying an upgrade, specifically to upgrade your Ender from a 4-point bed to a 3-point leveling system, because it is frustratingly difficult to level a bed with 4 points. Whereas, because when you adjust 1 point, it throws the rest of the bed out of whack. Whereas if you get a 3-point bed leveling system underneath, you are only leveling it in 2 axes. You are doing one side to side and then one up and, like pitch and roll, right? And so it makes it so much easier. There's a couple of different places that make them. They're fairly cheap. I think they're under $100. One is I got mine, I think, from Gulf Coast Robotics. Let's see
Check
here.
that out. Because yeah, I hate doing it's this right with the paper. You're like this,
Right. So you will
you're
still
dialing it, and
yeah,
you're waiting for it to catch.
you will
Yeah.
still use the paper and do it. You just have one less adjuster on the underside of your bed.
Right. Yeah, but that actually makes sense. That makes total sense because yeah, like you said, the 4 points is like you adjust one, and then now you've got the 3 off, and you're like, oh, right now I gotta, yeah. So that,
yeah,
I gotta look into that for sure.
I'm looking to see.
While you're looking for
They
that,
used
we
to have a
do have to
website.
start wrapping this up because it
Yeah.
is 1:30 Eastern. I'll have to get back to work soon, but
No, I don't want to. Let's keep talking about.
I know so many more questions.
Okay,
This has been great.
There's a couple questions I can answer really quick.
All right,
So-
rapid fire.
Have they made drones that can have batteries hot swapped midair? There are drones that have like a secondary power system in them, but not the battery can be changed out. And you would want to use a perch and stare repeater when you're placing it in a unplanned location that you cannot get to, because to set up a balloon or a kite or a rooftop node, you have to be able to get to it. So it's to put one in a location that would be advantageous for expanding the range of the radio net that you cannot get to.
Yep.
All right.
Also,
Evan, any final thoughts?
I'm going to be chilling in live event chat for the next half an hour or an hour. If anybody wants to keep chatting or has any more questions, just tag me so I see it. I'm Brock the Bare Bones, and I'll hang around and be more than happy to answer or find more information for you. In addition, because I know we're running out of time.
Yeah, I'll be there. Also, go ahead. QR code goes to everything that we've done, goes to our LinkedIn. So go ahead, connect.
And if that's in the slide deck, if you want a copy of that, it's in the Discord resources. What do we call that again? I got it hidden. Anyway, there's a resources channel on Discord, slides resources. You can find it there. If before we sign off here on Zoom, it's also here on Zoom. We will also add that link for the slide to the YouTube description right after we end here. So you'll be able to catch that slide deck with the QR code on it and all of the great information. We thank you for joining us for today's action-packed, in-depth anti-cast for today. Everybody who's in the United States, happy 4th of July coming up this weekend. We're not having a BHIS webcast because we know that people are going to be traveling for the holiday, including some of us. So we've got a break tomorrow. We'll be back the next week for more webcasts. And go to poweredbybhs.com to see all our upcoming webcasts, including our big AI summit coming up in August, the Age of AI, Infosec in the Age of AI. I think that's the title. Sign up for that. It's free to sign up. And I think we're working on wrapping up the schedule for that and all the talks that we'll publish within the next week or so. So we got a lot more coming from us in the future. Thanks for being here. Get back to work. And Kevin and Alan, you guys can kill it with fire. Bring me up the promo slide. I'm running half of it on my end, so I have to go and do the things on my side. So I'm going to do that once they give me the promo slide. No, that's Connor. We got Connor.
Me.
There's the promo slide. All right.
I am your promo.
Thanks, everybody.